Have you ever stood on a beach and watched a ship sail away? It's pretty cool, right? But have you noticed how it doesn't just get smaller and smaller until it vanishes? Instead, it looks like it's sinking. The bottom part, the hull, disappears first, and then the mast is the last thing you see. That's not just a cool trick of the eye. That's one of the oldest and simplest proofs that we live on a curved surface. If the Earth were flat, the whole ship would just shrink into a tiny dot. Let's talk about something else that happens in the sky: a lunar eclipse. When the Earth passes between the sun and the moon, it casts a shadow on the moon. And what shape is that shadow? It's always a perfect, round curve. No matter how the Earth is spinning or where you are in the world, that shadow is always circular. The only shape that can cast a perfectly round shadow from any angle is a sphere. A flat disk would sometimes cast a thin oval shadow, but that never happens, and you don't even need a telescope for the next one. If you've ever been lucky enough to fly in an airplane on a clear day, especially on a long-haul flight, look out the window. At 35,000 feet, you can actually see the curvature of the Earth with your own eyes. It's subtle, but it's there. The horizon isn't a perfectly straight line. It's a gentle, sweeping arc. The same thing happens when you climb a really tall mountain. The higher you go, the farther you can see, and the more pronounced that curve becomes. Here's a daily life example: time zones. Why is it that when you're having your morning coffee in London, your friends in New York are still fast asleep, and your pals in Tokyo are already finishing their workday? It's because the Earth is a rotating sphere. As it spins, different parts of the globe face the sun. This creates our cycle of day and night. On a flat Earth model, the sun would either be visible to everyone at once, or it would have to act like a weird spotlight, which doesn't really make sense with how light works. The existence of time zones is solid proof of a round, rotating planet. And what about gravity? Why do we stick to the ground? Gravity is a force that pulls everything towards a center of mass. For a massive object like a planet, gravity pulls everything towards its core, equally from all directions. This naturally pulls matter into the most efficient, compact shape possible: a sphere. It's why raindrops, bubbles, and planets are all round. A giant, flat disk would have some very strange gravitational effects, with gravity pulling you sideways as you got closer to the edge. But we don't experience that, do we? Travel a bit, and you'll notice something else. If you live in the northern hemisphere, you see the North Star, Polaris. But if you travel south of the equator, Polaris disappears, and you start seeing a whole new set of stars, like the Southern Cross. This wouldn't happen on a flat Earth. On a flat plane, you should be able to see the same stars from everywhere. They'd just be at different angles in the sky. The fact that entire constellations are hidden or revealed depending on your hemisphere is a dead giveaway that we're on the surface of a globe. Even something as simple as water tells the story. Large bodies of water, like oceans and big lakes, aren't perfectly flat. They follow the curve of the Earth. This is something engineers have to account for when building massive projects like long bridges or canals. They literally have to factor in the Earth's curvature into their calculations. For centuries, explorers and scientists have been gathering this evidence. Ancient Greeks figured it out over 2,000 years ago just by using sticks and shadows. Today, we have mountains of data from satellites, GPS systems, and space probes, all showing the same thing. We live on a beautiful, blue marble. All these pieces of evidence, from watching a ship sail away to looking at the stars, all point to the same undeniable conclusion. It's not just a theory, it's our observable reality. Thanks for watching, and don't forget to keep looking up and asking questions. See you in the next one.